I want to talk about truth functional logic. What truth functional logic is, it's a way of evaluating statements, comparing statements. It's a way of basically classifying statements. It's a way of comparing statements, and it's a way of determining validity using what we call truth tables. And what truth tables are is basically the idea that if you have a statement like B can be either true or false, right? Now, if B is true and I put a bar in front of it, then that means the function of this entire statement means that when B is true, if B is true, then bar B will be false, and if B is false and you have bar B, then that becomes a true statement. And so what happens here is truth tables basically are looking at every possible combination of a statement. If one part's true and another part's false, is this a true or false statement? Is this a true or false premise? And we can do that by using these rules. Now, the key is you need to know sort of up front, and you can memorize these. I think it makes sense to have some sort of idea. Once again, just as I did previously with the last unit, I told you that in the classroom I would typically give a quiz over these letters, these symbols. The thing I would also do in the classroom is I would give you a quiz over what I'm about to put on the board as a first step. Because if you can't kind of keep an eye in mind what each of these, what like B plus A, if B is true and A is true, that the plus would be true, then you really need to kind of get that down before you know anything else. And so the first thing you do is you need to learn how you translate these into symbolic form. And so I'm going to give you some examples, and I'll go through these 5, and then if you want to be a really good student, then you would want to sit down and go through these examples, or kind of memorize these examples. Just get a blank sheet of paper and force yourself to do it until you get it right. All right. So what happens is if you have a statement like bar B, then anytime the letter B is true, the bar is false. And anytime the B is false, the bar would be true. Because if B is true, then saying not B is a false statement. And if you say if B is false and you say not B, then you're making a true statement. So if I'm saying something like Bill is tall, and we know Bill is tall, and then I say Bill's not tall, then I'm saying that's a false statement because we know that Bill is tall, so if I say he's not tall, then I'm making a false statement. If Bill is short, and we know that's false, then when I say it's not the case that Bill is short, then I'm making a true statement. The next one is the plus sign. And we can have something like A plus B. Now in this case, A could be true while B is true. A could be true while B is false. B could be false and A could be true, false, and B could be true, and A could be false and B could be false. Now if I say something, let's just say for example, we have a statement like Al and Bill are here. Al and Bill are here. And let's suppose Al is here and Bill is true. They're both true. Then if I say Al and Bill are here, then we know that Al and Bill are here is a true statement. Fair enough to everybody? Then what we can do is we can then say, well, suppose Al is here and Bill isn't. What if I say Al and Bill are here? Well, then I've made a false statement because Al is here, but Bill isn't. So if I say Al and Bill are here, I'm lying. I'm telling you something that's false. And if Al isn't here but Bill is, and I say Al and Bill are here, I've made a false statement. And if neither of them are here and I say Al and Bill are here, I've once again made a false statement. So the only time that the plus symbol is true is if both of what we call the conjuncts, both the parts before and after the plus sign, are true. Otherwise, it's false. So then we go with like wedge. A wedge B. Once again, there's 4 different combinations. It could be true, true, false, false, true, false, true, false. And if I say something like Al or Bill is here, and we know both of them are here, then that's just a true statement. If I say Al or Bill is here, and they're both here, then I say Al or Bill are here, then that's a true statement. Now, if Al is here and Bill isn't, and I say Al or Bill is here, I've still made a true statement because Al is here. Al or Bill is here, So Al is here. If I say Al or Bill is here, Al isn't, but Bill is. Still a true statement. The only time it's false is if I say Al or Bill is here and neither of them is here. Then it's a false statement. The next one is, these are the ones that become maybe a little bit more, more interesting. If I say, if Al is here, then Bill will be here. This can be true, true, false, false, while B is true, false, true, false. And what happens here is, if Al is here, then Bill is here. If Al is here, that means Bill necessarily must be here. So if Al is here and Bill is here, then we know if Al is here and Bill is here, then we would go ahead and label that as true. But if Al is here and Bill is not, and I say if Al is here, then Bill will be here, but Al is here and Bill isn't, then we know that's a false statement that if I say if Al is here, then Bill will be here. Because if I say if Al is here, then Bill will be here, and Bill isn't actually here, but Al is, then I know that I've made a claim that's false. So we call that false. Now, if I say if Al is here, then Bill will be here, Al isn't here, but Bill is, well, in that case, this still could be a true statement. So we would label it as true, because it's the case that, say, for example, if I said, if George Washington was assassinated, then he would be dead. George Washington wasn't assassinated. That's a false statement. But he is dead, right? But it's still a true statement that if George Washington was assassinated, then he would be dead. That's still a true statement. So you can have a false antecedent and a true consequent and still have a true statement. And so anytime the antecedent's false and the consequent's true, we would still call it true because we don't know that it's false. There might be reason to think it's false, but for the best we know, it could be a true statement, so we would go ahead and label it as true. And just because both of them are false doesn't make the statement false either. For example, if the current president, Barack Obama, was assassinated, then Barack Obama would be dead. Well, that is a true statement, but it's false that he's been assassinated, and it's false that he is dead. So it's still a true statement, the if-then, but it's false, the antecedent and the consequent. So what happens here is basically, if the antecedent's true and the consequent's false, we know we have a false statement. But we don't know on the others. We would go ahead and say they're true because it's possible that they are true. And then last one is triple bar, A, triple bar, B. Once again, we can put true, true, false, false, true, false, true, false. Now in this case, A triple bar B is like saying A horseshoe B plus B horseshoe A. And so what happens is if A is true, then B is true. And if B is true, then A is true. Yeah, that works. That's fine. And just as down here, if F is true and F is false, it functions as the antecedent and the consequent in both cases, then we'll go ahead and call that true. But if the antecedent is true here but false here, then that's a false statement, which will make this plus sign a false. So we would call these false. If A is true, then B will be true, and if B is true, then A will be true. A is true, but B isn't. Well, then obviously it's not the case that if A is true, then B will be true. And if B is true and A is false, well, if B is supposed to be, B is true, then A is supposed to be true, and B is true, then F shouldn't be, they should be true too. So that's false. But they can both be false at the same time, just as they can over here. And so we know that if they're both true or they're both false, it's true. But if one's true and the other's false, then it's a false statement. So you need to memorize that, not because you can't just look back and have this next to you, but because it makes it a whole lot quicker. Because you're going to start doing some truth tables where you might have to fill in 150 T's and F's doing this. And it's going to take a lot of time if you have to look every single time back. And so it's best to kind of have that idea. Now, the first 600-700 T's and F's you write down, you'll probably be checking back. But when you do the next 6,000 to 7,000, you'll not look back nearly as much. You think I'm joking, perhaps. Maybe you think I'm being serious. I am actually being slightly serious. You will put a lot of T's and F's. But, you can type. Most of us can type. I mean, I can type like 60, 70 words per minute. A word is traditionally considered like 5 characters, which means, you can type 350 characters a minute easily. So, I mean, the same thing's true handwriting things. I mean, you know, it's like, oh, 300 characters I have to write out. Well, you know, that's a minute of work. I mean, you're not talking about a huge amount of work. All right, so yeah, I'm kind of being serious about you're going to write TNF 6,000 times in the next couple days, but, you know, that's not nearly as time-consuming as you might think. Now, what happens is we take this information, and your best bet, like I said, is to do this. But then what happens is we can use this information to find, like, if we have a statement like A wedge B, and I know A is true, and I know B is false, well, then is this a true or false statement? Well, A is true and B is false, so that is true. And so this is a true statement. But we can also use this to do more complex statements. Like if I had A wedge B horseshoe bar C, and I know A is true and B is false and C is true, then I can sit here and I can go, okay, A is true, B is false, and C is true. Well, this negates the letter, so we always do the letter in front of individual letters first, and so we would make that false. We kind of cross that out. And then we say, okay, true wedge false is true. So this is true. So true horseshoe false is false, which means that if you have a statement like, if Al or Bill is coming, then Cindy's not coming. And it's true that Al is coming and Bill is not and Cindy is, then we know that the function of this is a false statement. If you know the truth of all those, then you can determine the truth value of the statement as a whole by doing that. Now, that's all nice and good, but when it becomes fun, is what if we don't know if A is true or B is true? What if we're just guessing? Can we learn anything about these statements? Can we learn anything about validity by this information? And yes, we can. And that's where it gets really exciting. And so what happens is we can create these charts we call truth tables. And truth tables basically allow us to look at every possible combination of truth or falsity of a statement by creating a big table. So if I have a statement like A wedge B, well, in this case, we know we have two different characters. We know they can both be true. We can know A can be true while B is false. We can know A can be false while B is true. And we know they both can be false. And so we can then do a truth table which says true, 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 false. Meaning we can determine in what situations A is true and B is false. This is what I just did. This isn't anything new. But we can do this when we get into more complex statements. We can use this for arguments. We can do this for more stuff. I'm going to stop this here.